r is algebraically plus or minus 1 over the square root of pi, or the square roots of 1 over pi. Those two are equivalent. The square root of 1 is 1. In the context of this problem, do I really have two values for r? Or do I really only have one? In the context of this problem, we are talking about dimensions. We're talking about a measure. The algebra may yield me a very good algebraic value for a 0 to a function, which is what that value is. But in the context of this problem, it has no meaning. So let it go. So I need to check, using my first derivative test. I only have one critical point here so far. We haven't done the endpoint testing yet. There's v prime, 1 over the square root of pi. Let me bring up the calculator, approximately 0.564. So we would be okay putting 1/2 there and okay putting 1 there. We are going to take those values back and put them in for r into our derivative function. When I put 1/2 in, I get 1/4, so 3/2 minus 3 pi over 2 times 1/4 is minus 3 pi over 8. Too much for me to keep in my head. I believe I need a calculator again. That's positive. When I put in 1, this is going to be much easier, thank heavens. That's going to be negative 3/2 minus 3 pi over 2. I definitely have a max. So I have found a max value at that r. Let's have the endpoint discussion really quickly. I'm looking for volume. The smallest r could be is 0. The very smallest r could be is 0. Look at my volume function. If r is 0, do I have volume? No. I really, in the context of this problem, have an open interval. I don't know the largest r could be. It's constrained by the surface area. If I had no sides at all, if it was just flat, r could be 3. R couldn't be 3. Pi r squared could be 3. There's my upper bound. But again, my argument, I'm not going to mathematically find it, because if I do that, h is 0. And if I don't have h, I don't have volume. So I'm just going to put a question mark there. I have an open interval. I don't have endpoints as critical points to worry about. Now, let's answer the question, what height and base radius will maximize the volume? So we've done most all of the work. There's the base radius that will maximize the volume. I need to go back to my relationship function. When r is 1 over the square root of pi, what is h? My relationship function was a relationship between r and h. Right there. 3 minus pi r squared over 2 pi r. 3 minus pi r squared over 2 pi r. All right, so this is 1. Do we see that? 2 over 2 pi over the square roots of pi. Lots of algebra going on here, but will you trust me? You can pause the video and you can do that algebra yourself. We're going to have max volume when r and h both are 1 over root pi. So, final step, the volume. Ask in words, answer in words. will be A max when R and H equal 1 over the square roots of pi, back to the question for units, feet. Done. There's the third max-min word problem example. That's enough to get us started doing our first max-min word problems on our own. So come to class next time. We'll do some warm bodies to the board.